Hi there. In this video, we're going to take a quick look at how you can use the serverless functionality in Synapse Analytics to create or instantiate data into external table objects in the serverless compute node. So to start off, we are going to need a couple of things. The first thing we are going to need is some source data to work with. So obviously in the serverless model, you cannot work with physical tables, so you have to work with external tables, right? Um, so one of the ways that we're going to manage this is with create external tables as select. So if you want to instantiate some data, so for example, here we have a Hive database, right, where I have a set of uh, tables that I've built. Now these are AdventureWorks style tables, right? From the AdventureWorks sales database, and these tables I've created using a Juniper notebook that has been iterated and instantiated than Hive tables, right, from a source database. So now picture the scenario. You've now loaded your Hive, or your Hive table's been processed. They've been generating using the Spark engine from data frames. So you got a set of consolidated consolidated tables or consolidated artifacts that you now need to build out some form of data model on. So you need some dimensions and maybe some fact tables, right? In this example, I'm just going to work through building one dimension because the process would be the same, right? So we're going to use this address table as a dimension table. So let's quickly just show that. Okay, so there's some address stuff in here. And what we want to do is we want to use this this table as our source data. So first things first, we're going to need to create a database that we want to work in. So I'm just going to go ahead and we can use this, and we can say new Spark. Sorry, let's do here. I'm just going to create a new folder for this. So this is the Tech Labs, and this is going to be for serverless tables. Okay, so the first, we're going to create a SQL script, and first thing we're going to do is we're going to create a database. I'm going to call this database, I don't know, serverless warehouse. Okay. So that's the first thing. I'm going to execute that. Then, oopsie. Then the next thing we want to do is use, oopsie, I don't like that. My caps is all wrong. It's okay. It'll work for now. So let's just copy that. Right, so let's use that one. Cool. Boom. Oh, sorry. Let's just hit refresh. Right. Huh, that's strange. Not finding it. Okay, demo failure. Perhaps we should switch over to Management Studio and use that. So let's just go there. Let's have a quick look here. Databases. So here I'm connected to my on-demand workspace, as you can see. And you can see I have no dedicated pool. Okay, interesting. Well, let's just try it again from here. So let's go create database. Sorry, database. Let's fix these things, right? Let's just do everything lower. So run that. Ooh, sorry. Boom. Okay, let's not call it that. Let's rather do WH for warehouse. Oh man, there we go. Let's try that rather. There you go. Okay, and then we're gonna go and say use serverless where, oopsie, not twice. Accidentally push shift to insert. Right, there you go. Boom, now we're in serverless warehouse. The next thing, so we're gonna need a schema for our dimensions. I like to use dim, right? So we go create schema dim and hit F5. Right, so now we have in our serverless warehouse, I just want to go ahead and refresh so we can see the database, right? Here's our serverless warehouse, and we're all good, right? We should see our dim schema here too. Yay, there we go. Right, cool. So now we've got some of the basics done. The next thing we want to do, or we need to do, so we need to work with external tables. So I've gone ahead and prepared a little bit. So there are two things. Well, when we work with external tables, in serverless we only support native paths. So I'm gonna create first things first. We need a location, right? So we're gonna create an external data source, and we're gonna put this in our file system, our ADLS Gen 2 file system. So I'm gonna put it straight in the root of the file system, right? Go ahead and create that external data source in this database. The next thing we're going to do is we're going to need to create an external file format, and that external file format is going to be in Parquet. The next thing we need to do is, as I said, create the external file format because we need to work with Parquet. So we're gonna go ahead. So I've got ahead and I'll just prep that quickly. So just create an external file format. Go ahead, run that. Boom. And then what we need to do is now we need to think a little bit about how this is going to be constructed. So I'm going to now create my external table. So I want to create external table, and I'm going to call this dim for dimension dot address. Right, and then we're going to go and say width because we need to provide. This is going to be create external table as select statement, right? So we need to provide a location. So we do that location, and location should be where we want to place this in our file system. Now, if we look at, we probably need to come up with something clever here. So I probably want to create a curated location for this. So in the baseline file system, so we're going to start our location with a forward slash, right, for the root of wherever that data source is. And then I'm going to put in the word curated. as in, because we're using data lake storage, so we should use data lake terminology. And then I might want to put in the actual database name. So I called this, what do I call this? This is, well, serverless WH. So I'm going to use lowercase because obviously these parts are case sensitive. So as a standard best practice, lowercase, right? The next thing is I'm going to put in the schema name, so that's dim. And then I'm going to put in the table name, address. Right, so that is the location for my for this dim address. Okay. The next thing is we're going to need a file format or data source to work with. Sorry, so data source, and we're going to use this workspace file system. Right. And then we are going to need a file format. So file format, and we're going to use this Parquet file format we created earlier. Right. Boom. Then we're going to need some source data. So this is our generic create external table as select statement. So we go as, and then we go select. So this is very simplistic. Obviously here there would have been some business logic that would have gone into for this one, but this is just an example. So we're going to select star from, what was it? There's our Hive data .dbo because we come there's serverless, right? And then address. So let's just check that work quickly. And boom. Right, there we go. So there is our baseline data. So like I said, we would have had cleaned this up, done something with it, but this is just very simplistic. Right, so let's go ahead and run that. F5. Cool. And here we can see that it's completed, and we've written 2,250 rows. So if we now go here and we expand tables, and then external tables, we will see our dim.addresses. Cool. And this is now stored in a Parquet file format in this location. So if we now switch back to the workspace, we'll be able to go and select out of this one. So if we go here and just refresh the databases. Here we go, serverless warehouse, external tables, and there's our dim address. Cool. So now this can be used obviously in as a normal object. Happiness is, and if we want to have a look at where this is stored, so we can go through to our workspace file system, and we can see here we've got the curated folder. Inside of there we have our database, there our schema, and then address, and there's our Parquet file. So obviously this is a small single partition. It didn't split it up into multiples. If we now, we can now do the same thing with our fact tables. So I'm actually not too sure. Let's see if we can create one. I don't know if we have, I don't know what joins with the addresses, but if we, let's just quickly just check what we have here. Do we have an address ID? Ship to address ID. Okay, so it looks like This one has some stuff in it, so I don't know how much data is in here. Um, let's have a look. See. Oh, sorry, typo there. That can't be right. So only 128 sales orders. Oh, that was something boring. Let's see if we have anything else. We had quite a few addresses. So if we, so I don't know, I haven't really looked um, um, at the data, but let's have a quick look. Let's just switch over to Management Studio, and let's have a look at this hard table and see what we have in it, or this hard database. Um, um, Perhaps, well, let's see how many customer we have. Do we have a no? Actually, that's wrong. Let's rather use the, even though we only have a small amount of rows. So let's rather use the sales order header, and we go select top 1000. I just want to quickly have a look at it and create an aggregation. So what I want is probably, I don't know, let's go with total invoice amount, right? So we're going to create a fact table for our sales order. So we want sales order ID is irrelevant. We want to do total due by, I don't know, by order date. So we don't care about that. We want order date, then we don't care about the due date. Don't care about that. Obviously, this is completely fictitious. This would be uh, not done this correct um, in a proper data warehouse, but we're just gonna, right, so here we go. We have a ship to address, so here we go. Perhaps FK ship to address ID. Right, let's make those two uppercase. And then we're gonna put that, since we have them as address IDs, and this is build to. And then we are, don't care about that, don't care about that. We're gonna care about total due. And we're gonna go order total equals sum, oh sorry, my bad, order total equals sum that. Nice and simple, don't care about that, don't care about modified date. Right, here's a fact table, and off we go. And then what we are going to do is Uh, we're now going to run this. So we're going to need some aggregations or group by clauses. So let's group this. Let's go group by those fields. Let's just see that this works. And we go execute this quickly. And there's our fact table. Right. So now we can take this query and we can go back to this guy and we can say, well, we also want create schema fact. Oopsie, sorry. Open that shift insert again. So we run that. Boom. And now we want to, and there's our select statement. So we want to create our fact table. So this is fact. And it is, what was this? So this was order value, fact order, sorry, fact order value. Cool. So now we need to update the path. So this is now fact, and this is now order value. Okay, so let's just quickly create that. Boom. Oopsie. Oh, sorry, my bad. I need that. Cool. There we go. So there's our fact table, and if we have a quick look at that fact table, so we go and refresh our external tables, and there's our fact table. We should be able to select out of this. So you might say now, okay, well, what's the point of doing this? You can just spin up a pool and off you go. Well, what if you want to have shared low-cost facts? So let's say you use Spark to compute or generate um, your tables, or do your general ingestion and your cleansing. And then you want to create your data model using serverless. You could write store procedures that rebuild these tables on a daily basis, and you can just fire those. You will be billed by your consumption at $5 a terabyte, instead of having to have additional compute nodes spun up, or yeah, in the typical use cases where you would then use this to load your reporting platform or your analytical tools like Power BI or whatever it is you're using, as a sort of a batch job operation on a daily basis. And it makes life really, really easy to sort of calculate how much everything is going to cost you. Cool. So I hope you enjoyed this example. As usual, I will put up the code. So I will turn this into um, an importable script, or I'll drop this code into the Tech Labs Git repo, and link to that will be in the description. Right. Have a good one.